You know, in the history of medicine, there are a few names that just carry this weight, and the plague is definitely one of them. For centuries, it was this mysterious, completely unstoppable force of death. But today, well, the mystery is gone. We've identified the culprit, we know its tactics, and we know how to fight back.
It's a name that really does send a shiver down your spine, doesn't it? The word itself just conjures up these images of pure fear and devastation on a scale that's, well, it's hard to even wrap your head around.
So, let's actually meet the villain behind all of this devastation. We're going to take a closer look at one of history's most effective and, frankly, notorious killers. This thing is a true master of biological warfare.
Okay, so its full name is Yersinia Pestis. This tiny little rod-shaped organism is responsible for some of the most catastrophic pandemics humanity has ever had to face. I know, it doesn't look like much, but seriously, don't let its size fool you.
So this bacterium has some key features that make it stand out. It's what scientists call gram-negative, which is just a way to classify its cell wall. But for a doctor trying to figure out what's going on, the real clue, the most crucial identifier, is how it looks under a microscope. When you use a specific stain, the ends of the bacterium soak up all the dye, but the middle part stays clear. And what you get is this classic safety pin look. It is a dead giveaway that you're dealing with the plague.
So how does a simple little organism like this cause such a complex and deadly disease? Well, the answer is in its absolutely devious arsenal of what we call virulence factors. You can think of these as its weapons, the tools it uses to just systematically tear down our body's defenses.
Okay, you gotta hear this. The centerpiece of its whole attack is something called the type 3 secretion system, or T3SS for short. The best way to picture it? It's like a microscopic molecular syringe. Seriously. The bacterium finds one of our immune cells, latches on, and then bam, it injects these toxic proteins called YOPs that just completely paralyze the cell. But wait, it's not done. Not even close. It also builds this protective shield around itself, the F1 antigen, that works like an invisibility cloak. And to top it all off, it uses an enzyme, a protease, to dissolve any blood clots in its path, basically clearing a superhighway for it to spread like wildfire through our bodies.
So once it's inside and it's on the move, this whole invasion leads to one of 3 different forms of the plague, and each one is kind of like a different battlefront inside the body. Now, how the plague spreads really depends on which form it takes. And here's the crucial difference, the one that keeps public health officials up at night. 2 of the forms, they don't typically spread from one person to another, but if the infection gets into the lungs, it becomes pneumonic plague, and at that point, it can spread through the air in respiratory droplets, which makes it by far the most dangerous of the 3.
Alright, let's quickly break down these 3 battlefronts. The most common one you've probably heard of is bubonic plague. This is where it attacks the lymph nodes, causing those infamous, incredibly painful swellings called buboes. Now, if the bacteria break out and invade the bloodstream, it turns into septicemic plague, which is a full-body, systemic infection. And finally, like we just said, if that infection makes its way to the lungs, it becomes the highly contagious pneumonic plague.
For centuries, this story pretty much had one ending, a guaranteed, grim one. But that is just not the case anymore. The whole narrative has flipped, and it's all thanks to modern medicine.
Today, we fight the plague with a swift, 2-pronged attack, detection and treatment. The absolute key here is speed. Time is everything. We have advanced PCR tests that can spot the bacterium genetic material in just a few hours. And as soon as we get that positive ID, we hit it hard with powerful antibiotics, like streptomycin or gentamicin, which are incredibly effective at stopping the infection right in its tracks. That combination of speed and targeted treatment has turned the plague from a near-certain death sentence into a disease we can actually treat. And this story isn't just about the past, it's a blueprint for the future. I mean, just think about that for a second. We took one of history's absolute greatest killers, this force of nature that terrorized humanity for centuries, and we brought it to heel, all through science, fast diagnostics, and effective drugs. It is a massive and frankly incredible public health victory.
So, when we think about the threat of new pathogens emerging today, the story of Yersinia pestis is more relevant than ever. Which kind of leaves us with a really important question, right? What can the lessons we learned from taming this ancient enemy teach us about preparing for the next unknown pandemic?